Hello, welcome to the Universal Analysis 2000 QuickStart course. My name is Peter Caulfield. I'll be teaching this course. I'm the Applications Lab Manager here at TA Instruments, and I've got some experience in the development of this program, so that's why I'm giving it. The first thing I'd like to do is thank you for being a customer. The fact that you're here at all now means that you've already purchased an instrument, and we appreciate that. In connection with that, we've designed a series of courses that are aimed at ensuring that our customers get maximum benefit out of their thermal analysis and rheology instrumentation. These QuickStart courses in particular, are intended to be taken as soon as you get your instrument installed with your service representative, and probably before the technical representative even comes in to give you some hands-on training. It's intended to basically get you up and running with the program. Now, this is a recorded class, okay? So in order to hear it, you have to have a sound card and speakers installed in your computer. If you have any questions during the presentation, note the slide number in the lower right corner, and then at the end of the course, I'll give you an email address where you can send in for questions. Also note that the WebEx player can be used to pause, rewind, etc. during the presentation. Okay, Universal Analysis is a sophisticated yet easy-to-use thermal analysis data analysis program. It's specifically designed for thermal analysis data. It was created by thermal analysts. The programmer who did the programming actually is a thermal analyst. He's one of the people that developed modulated DSC. It is extremely powerful. There's a whole bunch of stuff in there. There's checkboxes everywhere to give you all kinds of options. Everything can be saved. It's very customizable. There's a wide range of analysis functions. But yet, it's actually easy to use because there's a series of default settings that will be suitable for probably the majority of users, okay? And it's perfectly safe to start out with those and not worry about everything else. And then as you get more used to the program, you can start branching out and starting to look into all these various options that you have. Okay. As I mentioned, this course is intended to introduce the new user to Universal Analysis. Okay, I'm talking brand new user here, somebody who's like barely even turned on the program. For people with experience with Universal Analysis, there's a series of additional courses that we're developing. One has already been introduced. It's called Universal Analysis Part 1. And there's that course basically picks up where this one left off and gets into a lot more detail about a lot of these subjects. There'll be a subsequent advanced course on Universal Analysis to be released sometime in the future. You can look to our website when it will be released. Okay, now we're going to begin with the straightforward process of opening, displaying, analyzing, and printing a data file. Okay, we're going to keep it nice and simple. Just do the 1, 2, 3, 4 bit, and I'll show you what you have to go through. It's really not that complicated at all. Okay, and then what we'll do is we'll go on and we'll demonstrate various aspects, various functions and options of the program. Basically, when you're using the program, it boils down to 3 areas. Displaying the data, getting the data to look the way you want it, analyzing the data, analyzing the transitions that might be on the curve, and then once you do that, you want to get it out, get the plot, and get the data analysis results out to some other media, whether it's a printed page or a Word document or a PowerPoint presentation or what. All right. And then we'll finish up with a discussion about how you can customize the program to suit your own needs. And then we'll finish up with some talk about some online support options. Okay, now to start the program, this is the way the desktop should look when you first have your instrument control computer installed. I suppose I should mention now, too, that Universal Analysis can also be installed on your desk machine, your office machine. It could be installed on a notebook that you take home. It can even be installed on your computer at home if you want. It's not keyed, so it can be installed anywhere you want. And it's actually kind of handy to have the data analysis program in your office so you can analyze data files in your office as you're working on reports and stuff like that. So anyway, this is the way the desktop should look. Okay, so double click on that icon, And this is the splash screen that you'll see when the program's opening up. And then when you, this is the desktop you'll see, and then click on that icon up in the top left corner there, and a little folder opening up there, and you'll get this Open Data File dialog. Okay, this is basically a standard Windows dialog with a minor modification. So what you do now is you navigate to the folder that you're interested in. In this case, I went to the DSC folder and I picked the file quenchpet.001, and you'll notice over here that there's a preview of the parameter block information that's in the data file. So if you're looking around for a file and you're trying to figure out where it is, what you named it or whatever, you can click on this and you can see what information, what the file is, what the sample was, etc. Okay, this is the data file information dialog. You'll see once you click open on that Open Data File dialog. Okay, now you can use this dialog to select things like signals and units and data limits, and you can also use it to correct typos. So if you made a mistake spelling the sample name or spelling your own name or whatever, or if you want to add something additional to the comment, stuff like that, this is a place you can do it. Now, the program will already be set up with default values for signals and units and stuff like that. So if that's the way you want it, then all you have to do at this point is press OK, and it will draw the plot. Now, if you decide you do want to go and check out the units, then you can push this button over here, and you can use that to modify the signals that are going to be displayed in the plot. Okay, so let's push that button there, and you'll get this signal selection dialog. Now, you'll notice that there's four Y signals here. Okay, yeah. There's 4 Y signals here. Okay, and so you can pick signals for each of the axes. Okay, for this case, we're just going to do one axis. All right, so we're just going to pick Y1, and from this drop-down list, we're going to pick heat flow. Okay. Then you'll notice also that there's options for X-axis type. You can pick time or temperature. That's typically what you would do. You can also pick. You can also put a signal on the X-axis. Okay. I'm not going to get into why you might want to do that, but just be aware about the fact that you can actually do that. And over here, there's a choice for what type of signal you want, whether it's a normal signal or a log scale or a derivative. You can even take the inverse of the signal. Okay, once you get that stuff the way you want, you click OK. All right, you get back to this dialog, and if you want to check out the units, you can click on that. You'll see the units. There's different units for every instrument. So there's a combo list, drop-down list. You pull that down, you pick the units you want, whether it's normally it would be milliwatts or watts per gram. You can also plot calories if you like calories better. And you can do the same thing for all of the other instrument types. VGA's got weight as expressed as percent. You can also have it expressed as micrograms or milligrams, etc. Okay, so we'll get that stuff the way we want it, and then we just press the OK button. Just press the OK button over here, and we'll get this plot drawn like this. Okay, this is polyethylene terephthalate. Or PET. It's a semi-crystalline polymer. It's a useful demonstration file. That's probably why we use it. It's got a number of interesting transitions. Okay, I should mention that it's a semi-crystalline polymer. Okay, that means it has an amorphous phase and a crystalline phase, and it undergoes transitions of both of those phases. The amorphous phase undergoes what's called a glass transition, and that's seen as a step change in the heat flow curve. And you can see that right here. When you heat the amorphous phase up, it can continue to crystallize. So as you heat it up, you'll see a crystallization exotherm right here. Okay? And then as you continue to heat it up, you'll end up seeing a melting endotherm over here. Now, if you want to analyze these transitions, you go to the Analyze menu and select Glass Transition, okay? So let's start with that one. So select Glass Transition over here. And then what you do is you position the cursors. You're going to get two cursors, okay, and you position the cursors in the flat region of the baseline before and after the TG. Okay, then you right-click and you say Accept Limits, okay, when you're ready. Now get the cursors to the point you want, right-click, and then select Accept Limits. Okay, and then it's going to go and draw this on there. Now, what it actually did was, at each of those 2 points, it took a piece of the data and did a linear regression best fit, and then drew a line at that best fit. Did that both for the baseline before and after the transition. Then it goes, in this case, it looked at the inflection point and fit a line about the inflection point, and then it displayed these labels. Now, these labels are as specified in the analysis option, so you actually have the choice about what labels get displayed. We'll talk about that in a little bit. Okay, so now if we go and select Integrate and Analyze Integrate Peak, you'll end up getting a another right drop-down menu here that has several baseline options. Okay, we're going to stick with the linear baseline option. That's the one that's used for when you have straight baselines, well-behaved peaks. You don't always have well-behaved peaks, and for that reason we have other baseline types called sigmoidal horizontal, sigmoidal tangent, and extrapolated. There's also some other options that come up. Once you have a peak integrated, there's other options like perpendicular drops and running integrals that can be used. We talk about that stuff in detail in the next class, but for this one we're going to basically just stick with linear baselines. Okay, so now you position your cursors on the baseline region before and after the peak. Okay, then right-click again, just like before, and say Accept Limits, and it will draw the peak, and it labeled it with the peak height and the onset temperature and the area. Okay. Now again, that was specified in main options, and you got the choice on how that gets labeled. We'll come back to that in a minute. So now we can do the same thing again for the melting endotherm. Position your cursors, say Accept Limits, and it will draw the peak. Okay. So now that we have the peak, now we have the curve analyzed. Okay, you simply go over to File, Print, select Print, and you'll get this dialog. This is a standard Windows dialog. Whatever printers you have installed on your computer will be listed from this list. Whichever one is the system default printer will be the one that comes up. So you just select OK, and this is the print that you'll get. Okay, so it's really a very straightforward. It's really a very straightforward process to open a file, display it, analyze it, print it. There's really not that much to it. Okay. Now, obviously, that was greatly simplifying things, so there really are a bunch of other things that you can do, okay? And I think that's the focus of the rest of the class. So now I'd like to describe various other capabilities and options of the program. When you're considering how to display the data, okay, there's various options that you can use for, there's various functions that you can use for rescaling data. Okay, so we'll get into that a little bit. Then there's graph options, which allow you to control things like, attributes of the plot, like the curve color, the curve line type, whether you use symbols and stuff like that. Those are actually pretty powerful too, because you can save those for different axes, can have their own options, and different instrument types can even have their own options. There's various tools that you can use, such as smoothing, rotating, shifting, stuff like that. We'll talk about those a little bit. That's also where you do baseline corrections if you need to. There's two other display options that are really powerful, and I'd like to talk about them briefly. Those are covered in detail in the next course, but I'd like you to walk away from this knowing that they exist. You can explore them on your own, and then if you can't figure it out, there's online help, and you can always call the hotline and then take the next class. Then we'll get into, those two functions are the inset view and the curve overlay. Okay, by the way, sorry about that. Then we'll talk about various analysis functions, a little bit about how they work, what options you've got as far as what kind of results get displayed, things like that. And then we'll get into some detail on how you export plots to other applications. You can also export data as well. And then we'll finish off by, and those are the three main aspects of the program: displaying, analyzing, and exporting. And then we'll finish off by talking about how to customize the program get it to be the way you want. There's extensive amounts of saving stuff, so you can really get the program to be the way you want. And then we'll finish off with a brief discussion about what kind of online help is available and what kind of support options you have. Okay, so let's start off talking about rescaling display options. Okay, so the two main options really are manual rescale and cursor zoom box. Okay, so if you go to rescale manual, you'll get this manual rescale dialog, and in there you can put in explicitly what start and stop points you want for the X and Y axes. Okay, you can do them, all four Y axes can be done independently. You can specify at what interval you want labels, or what intervals you want ticks, and you can even put an offset in before you have a label if you wish. Okay, so this is the plot that we started out with. So if we want to rescale this, let's say we're going to rescale this transition in the middle here. Okay, what you can do is you draw a box. You take your mouse, you go to the upper right corner over here, and you click on this spot, and you just draw down over to here. Okay, and you'll get this zoom box. Okay, and you draw that around the region you want to display, and you right-click within the box, and you'll accept that you'll accept those limits, and the plot will be rescaled. If you right-click outside the, if you click outside it, it will erase the zoom box, and you can try again. And if you right-click outside it, you'll display this menu shown, and then you can accept limits. There's also these other things here for inset views, which we'll get to later. Okay, so now we accepted those limits. It redrew the scaling. Okay, there's other scaling functions as well. You can zoom out if you just want to zoom the scaling out in steps. Previous limits is really handy. Whenever you do something, you can undo it. Okay, there's only one undo, so be careful. And you can hit Control U to undo that. Okay, you can always go back to full scale. So if you're zooming in, you decide you don't like it, you can always go back to full scale. There's other things here called common scale, same scale, stack axes. These are disabled now because they only have one axis plotted. We talked about them in the first advanced class. They're useful when you have signals on multiple axes with the same unit types and you want to get them to scale the same amount. When you draw zoom boxes around stuff, when it rescales it goes up to the next logical tick mark. And that can sometimes be a little bit annoying. So if you want it to go to the exact X and Y coordinates that you draw with the zoom box, it will do that if you check over here. Okay, so you got to do that. All right, now there's a couple of different graph options and tools that you can use to manipulate the way the data looks. Okay, so if you've got your curve drawn already, and if you select graph options from the graph menu, you can modify various elements of the plot. Okay, this is a dialog you'll get. Okay, you'll notice up here that there's separate radio buttons for the different axes. Okay, Y2, 3, and 4 are grayed out because I don't have curves drawn on them. But you can set all of these things independent for each axis. That's exactly what I just said. Okay, so if you want to select colors, you just go over here to this color, and there's a drop-down combo list here. You just drop that down and scroll down to the one that you want. Okay, and forevermore, Y1 can be blue if you want, or you can make them any colors you want. Okay, you can also select line types. So if you want Y1 to be, say you don't have a color printer, okay, you can make Y1 be a solid line, or Y2 be a dashed line, and Y3 be a double dashed line, or whatever, you know. Okay, you can also use symbols. Okay, if your symbols are, people that do DMAs like symbols. So if you do want to use symbols, they're there for you. They're actually useful if you don't have access to color printers and copiers, and you need to differentiate multiple axes, multiple curves. You may need to resort to symbols. Okay, so get all that stuff the way you want it, press OK. And there's a bunch of tools that are available here. I'm not really going to get into these a whole lot. I'm not going to show you examples of them or anything like that. I just wanted to mention that they're there. Okay. They probably should be used carefully by the novice user because it is, changing the data. Smoothing is a useful function if used properly. It can be used to eliminate short-term noise. So if you're looking at a very weak transition, smoothing can be effectively used to eliminate short-term noise and improve the sensitivity. It can also, if it's overused, it can actually distort the peak shape. So you really need to be careful about it. And if you are going to be smoothing, you should be smoothing in small steps and looking carefully for evidence of peak distortion. Okay. There's also a function here to shift curves up and down. That can be actually useful if you've got an overlay plot, multiple curves, and you want to shift some up and down to get them to line up nicely if you want to compare them. You can also rotate curves. So if you've got some really wicked baseline slope and you've got a very small transition on a very big baseline slope, you can actually take that curve, rotate it horizontal, and then expand up that small transition. Hopefully you won't run into problems with nasty baseline slope, but sometimes it happens. You can also do a linear transform on data. So if you wanted to do some mathematical manipulation of the data, it would have to be simple, just a linear transform, so you could add or subtract numbers to it, or you can multiply and divide. So you can add, subtract, multiply, and divide to any one of the signals and transform it into some other value. There's various reasons why you would want to do that. I'm not really going to get into that now. I actually do show an example of that in the next course. The baseline file or baseline correction function is used when you want to subtract a baseline file from a sample run. Hopefully you don't have baseline problems and you don't need to do that, but sometimes when you're looking at very small transitions, very small weight losses, things like that, you need to subtract out the baseline effects. That's particularly more of a problem with the older instruments. Okay, now it's important to remember that these functions affect only the data displayed, printed, or exported. Okay, it does not change the original data. Okay, so you can mess around with these things and not have to worry about destroying your original data. Okay, that's the good thing. Bad thing is that these changes aren't saved unless you explicitly create a new data file. Okay, so you have to create a new data file in order to save these modifications. Okay, so keep that in mind. If you painstakingly tweak something to get it to be exactly the way you want, then you're going to have to remember to write a new data file. And I strongly, strongly emphasize, underline, exclamation point, that you save it with a different file name and don't overwrite the original data file. Okay, that's actually very important. Okay, now I'd like to talk a little bit about inset view and curve overlay. These are two really nice features that are built into this program. They're a little bit on the advanced side, so I'm not going to get into them that much in this course, but I want you to walk away from this knowing that they exist. Okay? Inset view is designed to highlight a small area of the plot while still showing the full-scale plot. It's basically a picture within a picture. Okay, so if you look at this plot, and you look at that glass transition, and you can see how the labels are really kind of scrunched up there, a little bit on the crowded side, and it's a little bit hard to see the arrows on the transition. It looks a little, So what the inset view does is you basically just draw a zoom box around the transition, and then right-click here on Auto Inset View. So you right-click outside the box, the zoom box. You'll get this dialog, and you select Auto Inset View. And you'll get something that looks like that. It's actually really pretty cool. Now you can take that and drag it around. Now you can drag it to take it from here. You can drag it to over here. You can resize the size of the region plotted. You can resize the size of the inset view. And if you right-click on this, okay, you'll get the edit. You get a series of options. Okay, you can adjust the view and adjust the region, like I just mentioned. You can adjust the position of this arrow. You can delete the inset. That's how you delete it. And you can also go to the Edit Inset dialog right over here. Okay. And if you go there, you get various options that you can use to manipulate the customize is a better word, the plot. That's what controls whether there's an x-axis on it or a y-axis on it, stuff like that. Okay, you can explicitly define regions that are plotted, things like that. Okay. Now, curve overlay is a really powerful feature. Okay, it lets you combine curves from different experiments on a single plot. Okay, they can be from different instruments, even. You can overlay up to 10 curves on each axis. Okay, whatever you put on each axis has to have the same units. Okay, so you can overlay up to 10 curves on each axis, and you can use up to 4 axes. So you could conceivably overlay up to 40 curves with the same type on all 4 axes. Okay. So if you're doing a QC application and you want to compare all of the runs from a QC run, from a production run, you could make a plot with 40 curves on it. Okay. This allows you to make comparisons of up to 4 different signals. Okay, so they can be from different instruments. So you can do a DSC. Say you were doing a thermoset curing material or something like that. You could do a DSC of the curing exotherm and a DMA of the modulus increasing and tan delta going around, stuff like that. Even overlay a TGA plot showing decomposition, stuff like that. So you can show multiple techniques on the same sample, or you could show multiple samples on the same plot. It's really pretty handy. You can now create multiple curve overlay plots. Okay, so you can create, I think it's up to 20, in the same session of UA, and each of those plots can be labeled with its own name and stuff like that. Now, it's important to remember that a overlay plot is actually just you're not at the data again. Okay, you're creating a new window that UA is tapping data from an existing window into. It doesn't actually exist. It's not really a file that you open up and create or anything like that. Okay, it's just actually a window which goes and snatches the data from various other files that are already opened. Okay, that's kind of what it is. So in order to save an overlay plot, okay, you have to use the Save Session feature. Okay, and I'll get into that in a minute. Now, to prepare an overlay plot, first thing you do is you open and set up the individual files to be compared. Okay, and then you select from the graph menu, Overlay, Auto Configure. Okay, and you'll get this dialog here. Now, mainly, now in this case, I've got 4 files open. I want to overlay all 4, so they're all checked. I don't have to worry about that. If I had other files I didn't want to overlay, I could uncheck them, and they wouldn't get overlaid. If I had multiple axes open, I could uncheck the other axes. They would or wouldn't get plotted based on a check mark. But right now, I've only got 1 axis. I want to plot all 4 curves in the overlay. And basically, the only decision I have to make is how I want to differentiate the curves. And this section highlighted in red here tells the program how you want to differentiate axes versus curves. Okay. Now, in this case, I don't have multiple axes. I just have multiple curves, and I want to differentiate them by color. So I have line type and symbol deselected, and I check the color box, and I push the radio button for curves. And what that's going to do then, when it creates the overlay, it's going to use color to differentiate the curves, which is exactly what I want. And that's exactly what I got. Okay. Now, up until now, I've been showing everything full scale. This is a cascade view of the plots. If you want it to be full scale, this little icon right over here, this is standard Windows stuff. This business over here. Just press on that button there, and you'll get a full-size plot. Okay. So this is an overlay plot of an isothermal curing of a thermosetting epoxy resin. This is for something I did when I was working in engineering. Basically, you vary the isothermal cure temperature, in this case from 135 to 150 degrees, and you can look at how fast the reaction proceeds at the various temperatures. It's actually kind of a nice plot. Now, the overlay plot, once you've created it, you can modify it using the overlay edit feature. So in this case, you see all these red boxes, and then you'll notice where it says Curve Overlay 1. If there are multiple curve overlays, you'd see Curve Overlay 2, Curve Overlay 3. You also have the ability to rename the Curve Overlay 1 to, Overlay Isothermal Curing or whatever. So if you have multiple overlays, you can give them descriptive names. Now, this is the Edit Overlay dialog, and from here, so when you create the overlay, if you decide you didn't like the color choices or something like that, you can go back in here and explicitly change the colors. You can also, over here, write a bunch of text that will, this is by default the label, the sample name rather. Okay, it's labeled with the sample name by default. Okay, but you could also go and create customized text in the space over here. Okay, and that will show up on the legend over here when we make the plot. Okay. Now, once you go through and get this thing exactly the way you want it, okay, you got to remember to save it. Okay, and the mechanism to save an overlay plot is the Save Session feature. Now, I should mention a little bit about what the Save Session feature is. Save Session saves the entire state of the program as a single file that can be restored at a later time. The entire state of the program, everything, every single file that's been opened, each of the signals that's been chosen to be plotted and how you wanted it, all of the graph options, all of the scaling that you used, any analysis that was done, any annotations, anything like that, all of that stuff, everything that's in UA's memory at that point in time gets saved into one file. Now, when you go and open that file up again, you'll have your overlay plot. Okay, it's also very useful, aside from overlays. Okay, if it's the end of the day and you're going to shut your computer down and you want to pick up where you left off tomorrow, you can just save a session file. When you come back tomorrow, turn your computer on, and you open up the session file and you pick up right where you left off. Okay, so it's really a very, it's a very handy function. Now, Save Session is different than Save Analysis. So I just want to mention that right now, and I'll come back to that in a couple minutes. Okay. Now, so that's it for the various display options. Okay. So let's get into the analysis functions and options right now. There's a couple things I'd like to mention before we get into it. Okay. And the first is that UA automatically adjust the available analysis functions based on the signal type selected. Okay, so if you're looking at a DSC, you're going to see the DSC analysis functions. If you're looking at a TGA, you're going to see some more functions that are specific to TGA, as well as some generic ones that are specific to all signals. Same thing goes for TMA. You'll see some expansion coefficient functions and stuff like that. All right? Now, this is something we didn't do in a simple example before, and I'd like to get into now a little bit, is that you always want to optimize the scaling of the transition you're going to analyze before you analyze it, okay? Don't try analyzing a teeny tiny transition, okay? It's really hard to place the baseline limits correctly when you're looking at a very small transition, all right? You've got a full-size screen, blow the transition up all the way, and then look at it carefully when you really want to carefully consider where you put the analysis limits, okay? Because it will affect the repeatability of the measurement, all right? Now, we don't really have time to get into this subject very much right now, but I really want to emphasize that analysis limits will influence the values you get. So you really want to carefully consider that, okay? This subject I cover in considerably more detail in the next course. Now, when you do an analysis, various information gets displayed on the plot, okay? And in analysis options, you can customize what information gets displayed after you do the analysis. That's really a nice feature because you don't really want any more information on there than you really need. So you can consider how much you need on there and put on exactly what you need, okay? So this is a DSC curve we've been looking at all this time, okay? So at the top of the analysis menu here, you see these analysis functions that are specific to a DSC, okay? Stuff like glass transition, oxidation temperature, purity, okay? Those are all DSC-specific functions, as well as some other generic functions that apply to all of them. Now, this is a thermogravimetric analysis of a sample happens to be another demonstration sample called calcium oxide monohydrate. And this sample has a number of nice transitions, okay? And when you go to the Analyze menu now, you'll see these same, you'll basically see a new set of analysis functions that you didn't see before, stuff like weight change and temperature at weight percent and residue and modify size. Those are all functions that are specific to a TGA, okay? You'll still see all the generic functions, okay, that are common to all signals. So any signal has got this generic set of functions that are available. And then the specific functions are basically enabled and disabled based on the signal type that you select. It's really kind of handy. That way you're not looking at a bunch of stuff that doesn't really pertain to what you're trying to do. Okay, now you always want to optimize the scaling of the plot scaling before you analyze. Okay, so if you're going to analyze this TG over here, okay, you really want to go and rescale around that first. Okay, don't try working on something that small. Now, if you draw a zoom box around that and then accept limits, okay, you'll get something like this. And then now we select Analyze Glass Transition, okay? And now you're going to get two cursors. Now, this is the kind of point I was trying to make here, was that before, at the higher scaling, you really couldn't see the fact that there was a little bit of slope going on here, then it flattened out a bit here, and you didn't really see that there was this thing going on over here, okay? So that's kind of, you know, that's not obvious unless you blow the scaling up, okay? So now what you want to do is you want to position the cursors on the baseline region before and after the TG, okay? Then what the program is going to do is it's going to fit lines at those points and draw lines out. So if you pick the point back here, okay, you'd end up with a line going something like that. If you pick the point over here, you'd end up with a line that was doing something like that. Okay? It's not really the right way to do it. Okay? You want to pick the region of the baseline on the flat region right over here, okay, and right over here, okay? And then what the program is going to do is it's going to draw a line out like that and draw a line out like that, which is what we want, okay? So just right-click and say Accept Limits, and the program will do exactly that, okay? It's going to label this curve with the things that you want, okay? What it did was it went to this point right here, looked at the data, did a linear regression, and sent the line out. Went to this point, looked at the data, did a linear regression, sent the line out. It looked at the data in between here, found the inflection point, looked at the data, did a linear regression, and drew that line. Okay? The intersections of those lines here are the start and stop point, the onset and end set temperature, and the inflection point is the glass transition temperature. Now, that gets us into another subject, which is the how do you label a midpoint of a glass transition? Because a glass transition is a transition, hence the name transition. It's not a temperature, a unique discrete point where something happens. It's actually defining a range. So typically we assign a temperature to the range, okay? And there's a couple different options on how you do that, okay? Inflection is actually the default option right now. So if you go to Analysis Options, okay, under Step Transition here, you'll see how it defines the midpoint at the TG, and then the default is the inflection, and the default labels are onset and end, okay? Now, there's other options on how you define the midpoint of the glass transition, okay? My personal preference, okay, is to use the temperature halfway between the height. It's called the half height. Temperature halfway between the height of the baselines before and after the transition, okay? The glass transition is a transition between a hard glassy state and a soft rubbery state. It's a transition of the amorphous phase from a hard glassy state to a soft rubbery state, okay? So you look at the baselines before and after the transition, and that's what this is. Okay, and that's what this is. Okay, so if you want to put a temperature on that, okay, the halfway point between here and here is a fairly logical way to put that. Okay, so that happens to be my personal preference. You can do it however you want, though. Okay, so if we go to integrate peak again, and we do that, okay, now you have a couple baseline options here. We've only talked about linear baselines, but there's also what are called sigmoidal horizontal, sigmoidal tangent, and extrapolated baselines. Now, those three baseline types are, well, let me start this way. A linear baseline is when you have a nice, well-behaved peaks. Nice, well-behaved peaks, okay? The other three baselines are for when they don't well-behave, okay? And quite often peaks don't behave very well. That's just the way it is. Okay, so these are options that you've got for when the peaks are less than ideal, okay? I get into this in detail in the next class, so I'm not going to get into it now. We're going to just stick with the linear baseline, okay? So, you get your cursors, you want to put them on the flat region of the baseline before and after. This one gets a little bit tougher because you notice it's not quite flat over here, okay? But I'm going to pick 180 over here anyway, okay? Then I'm going to check off accept limits here, and it's going to go and draw. What it does when it does a peak integration is it goes to these 2 points here, draws a baseline between the 2 points, okay? Then it integrates the area under the curve to that baseline. That's this number here. Then, based on analysis options, okay, these are default conditions. It's going to go to the inflection point, fit a line to that data, and extrapolate this line out, okay, and get you this temperature here, which is the extrapolated onset temperature. Okay, then it goes to the maximum deviation from the baseline, okay, which is this temperature here. Okay, so by default it's going to label the peak max, the extrapolated onset temperature, and the peak area. Okay, and that's exactly what I just told you. So when you go to analysis options, okay, that's where you can control what gets drawn, okay? And what you just saw was the default options, okay? It calculates the peak onset here, calculates the maximum here, and it gives you the area here. Normally you get normalized area, normally normalized. But you can change these if you want, okay? So, often you want peak height selected, and width at half height is also a useful one, particularly when you're dealing with issues like optimizing methods development, optimizing resolution, considering sample size implications and stuff like that. It's also useful when you're doing modulated DSC and you want to know the width of a transition so that you can effectively define your modulation conditions. Okay, so now if I select those options, go back and redo the analysis now, I'll see that I also get a peak height calculation here, and I also get the width at half height. Okay, so it figures out the height of the curve and then goes halfway up, okay, and then gives me the width at half height. Okay, it's actually a pretty handy, it's a pretty handy feature actually. All right. Now, once you have labels on the plot, you can reposition them around by simply grabbing them and dragging them. Okay, you can move these things around if you want. This program is a right-click adventure. Okay, right-click on labels, and you can change the attributes, make them bold, italics, change the color, stuff like that. You can make them bigger. You can change the resolution. So if you want this to be 139.3, you can do that. You can also delete results, delete labels, and stuff like that. You can also copy text if you want to just copy it and then paste it into like something else, you know. I should also point out that when you can right-click on stuff like if you right-click over here, you get manual rescale. If you right-click over here, you'll get graph options. So it's actually, there's right-clicking going on all over the place around this program. Now, analysis results. Once you've gotten all of these results, okay, they can be saved, okay? And what it's doing is the data file consists of an ASCII block of sample information at the beginning, then a binary block of the actual data. And then at the end of the data, when the run is completed, a method log, which is actually binary also, is appended to the end of the file. And then after you start analyzing it, UA can also append what's called an analysis record to the end of the file. Okay, and this analysis record is also in binary. You can only view it with UA, but it contains all the information that UA needs to restore that plot exactly the way you had it. So when you say save analysis, you're saving all the analysis that was done, all the labels that are on there, exactly where they're positioned. You're also saving what signals are plotted, what the scaling is. So it's actually a way of getting that plot back to the way it was when you saved it, okay? So if you consider the difference between the plot, the way the plot looks now and the way the plot looks when you first opened it, okay, that's what you can save with save analysis, okay? It's important to note that there's only room for one analysis record on each data file. So if you save an analysis and you go back and then you do it again and you save it again, you're going to overwrite the original one. Okay, that's why when you hit save analysis, it always takes you to a data file name dialog. Okay, regular Windows dialog where you can specify the file name. Okay, if you use the same file name, it's going to prompt you that you're using the same file name. Do you want to overwrite it? So if you don't want to overwrite it, then you can save multiple analysis records, but you just have to give them different file names. Okay. You can also remove an analysis. Normally we don't bother removing an analysis, but you just simply override it, you know. All right, now we should get into the business about exporting plots and data now. There's really a whole lot you can do with that, so let's get into that now. Basically, the simplest exporting plot is a print. A print is actually an export, is an exported plot. Okay. Now you can also export plots in addition to just the printer. You can export to Microsoft Word, PowerPoint. You can actually create Adobe Acrobat PDF files now with this program. Okay. You can also export new data files. Okay, so this is how you create new data files. So when I was talking to you earlier about using tools and smoothing and shifting and applying baseline files and things like that, if you want to save that stuff, you have to create a new data file. This is how you do it with the export data file function. Okay, you can also view data and results. Okay, you can view the raw data. You can view the numbers that you get as a result of an analysis. Okay, and you can do that readily using either a text editor or an Excel spreadsheet. Okay, the text editor is built into the program. In order to use Excel, you need to have Excel installed on your system. Now, there's print and print setup, print preview. Print setup is the standard Windows printer setup dialog. And if you select print, you're obviously going to get a print. And if you select print preview, select print, you'll get the standard Windows dialog. Okay. If you select print preview, you'll get this print preview dialog. Now, this is kind of handy just to take a quick look before you send it off to the printer or before you send it off to the clipboard. Just take a quick look at it. Okay. Now, from print preview, you can also export the plot as well as print it. So you could just say, okay, print it, or you can export the plot, and from that you can just like send it to the clipboard or send it to an image file or whatever. Okay. So this is the printed output that you get before. Now the way this looks is going to be controlled by some options, which I'm going to get to in a minute as soon as we talk about customizing. So all this information up here that gets displayed, that can be controlled in main options. Now, in addition to just printing, okay, you can output to Microsoft Word, PowerPoint, and you can make Adobe Acrobat files. So let's talk about that briefly. Okay. The easiest way to do this is simply to copy the plot to the Windows clipboard. Okay, and then from there you paste it into Word or PowerPoint. Okay, it actually copies a bitmap file to the clipboard. And from there, it's simply, and you can actually just do Control-C to copy it, and then jump into Word or PowerPoint and do Control-V, and it just pastes it in. Okay, that's the easiest way of doing it. There's another way, which I'll tell you in a minute, and it's a little bit more complicated. Okay, this works fine. Bitmaps work fine as long as you don't do a lot of resizing of the plot, make it real small, stuff like that. All right, so once it's on the clipboard, just open up a Word document, insert the insertion bar, and hit paste. Okay, and you'll get it. This is a Word document now with the plot drawn in it. Okay, you can do the same thing with PowerPoint. I recommend that when you make a PowerPoint slide, you select a new slide. When you select slide over here, select a new slide that has an object frame in it. You know how it's got that little object frame on it, and paste it into that object, and then the plot will be automatically resized to the size of that frame. Okay, you can also export to Adobe Acrobat format. Okay, so you can send files to people that don't have access to UA. Okay, that's really kind of handy. People used to send Word documents to people, but then you'd have situations where people didn't have Word either. So you do that, you're going to get this dialog. It's for for giving it a file name. What it's going to do is it's going to append a .pdf extension onto the standard file name. And once you do that, you can just open up the file in Adobe Acrobat. Adobe Acrobat Reader would typically be used. This actually is Adobe Acrobat, but that's just because I have it on my system. But that's really actually pretty handy. So now you can create read-only copies that people can't mess around with, and you can send it out to anybody, attach it to an email message, stuff like that. Okay. Now there's a function on the file called Export Plot. Okay, and you're going to get this dialog. Now this actually is a dialog that's controlling a lot of these details on how it exports plot. Normally it includes stuff like printers and plotters and clipboard. But the main reason for this is if you want to export to a file. So if you want to make an image file, okay, you can browse to location, give it a file name, okay, select the type. By default, it's an enhanced meta file. It's a Windows format, okay, and you can click export, okay, and it will then create a image file of the plot with that name, okay, and from there you can then go to say PowerPoint and say insert image from file, and you can point to this EMF file and insert the image. Insert picture from file is what it says. Okay. This is also where you would control the pen width size. So if you want a wider pen, sometimes you might get in situations where pens look too thin and you need to increase them. This is where you do that. All right, now the situations where you need to create new data files, okay, and there's one thing we got to point out, okay, and that's the concept of file signals versus plot signals, okay. Now, a file signal is the original data, okay. It's what was stored in the data file. It was what was originally read into UA. Once it gets read into UA, it could possibly have been modified by UA, okay. You could have smoothed it, you could have taken derivatives, you could have done stuff like that, okay? Those are all now called plot signals, okay? If you want to save those permanently, okay, plot signals only exist in UA's memory. If you want to save them permanently, you have to export a data file and say plot signals, okay? So typically we would say file and plot signals, okay? You can always just go in there and explicitly select specific files. So if you want to create a new file with just one particular plot signal in it, you could do that. Now, you can also transfer data to either a text editor or an Excel spreadsheet. It's really pretty handy. Okay, so you can say view results, and you can say a view results report or view results spreadsheet. There's also view results options, which controls what results get viewed. Okay. There's a text editor, simple text editor, kind of like Notepad, built into the program. So if you view results report, you're going to get the reports in a text editor format. Okay. You can then take them, copy them, do whatever you want with them. Okay. If you view results spreadsheet, it will actually open up Microsoft Excel, take the results, and paste them into a worksheet in Excel. Really very handy feature. You should never have to copy. You should never have to manually enter numbers into Excel. Okay. This, of course, requires that you have Excel installed on your computer. Okay. So if you say view results in spreadsheet form, this is what you're going to see. Okay. So I've actually got a copy. So now you can take this and you can do all sorts of stuff with this once it's in Excel. It's really very handy. All right, now we're coming up to an hour now, so we should probably wrap this up. There's a couple things about customizing the program that we should talk about briefly. Okay. When the program started, it's initialized with the default set of parameters. Okay. Once it's opened, the user's preferences can be saved to this initialization file. We call it an ini file. Okay? Multiple users can have their own ini files. Most people really don't take advantage of that, but if you did, if you wanted to, you could. Virtually any relevant parameter can be saved. Okay? Simply press the save button whenever you want to save that option. So any dialog you're on, like graph options or signals or whatever, select the things that you want, hit the save button, and from that point on, for every file that you open, you're going to have those options selected. Okay? The default options can be easily restored. Individual dialogues often have a default button that will reset everything back to the default, and you can also reset this whole system defaults back. So if you go into File Options, you get this dialogues, a whole bunch of tabs here. Okay. First thing I'd like to point out is the Export Plot tab here, and what you can do with that is you can control the header information that's displayed. So if you want to turn off the comment field, okay, or whatever, turn off the operator name or the file name or something like that, and you could do that. You could also turn off everything over here and select custom text. So if you're going to paste it into a report, for instance, you might want to turn off all that header information, okay, and then just go and write some custom text like Figure 1, this is this, that kind of thing. Now we haven't talked about this before. But there's a toolbar at the top of the program. That's customizable. Okay, so you can go down here and check. There's a whole bunch of them. Okay, you can check which icons you want displayed on the toolbar. Okay, and then you do that and you click the save button here, and they're saved. That'll be that way every time now. There's various sets, so you can get just the DSC ones, just the TGA ones, stuff like that. The icons are automatically enabled based on the signal type selected, so you'll notice that there's a bunch of grayed out ones over here. Okay, these are all TGA and TMA analysis functions. This is a DSC file, so they're grayed out. Okay, there's a toolbar icon for every function. Okay, so if you're into icons, okay, you can pick icons for your favorite functions and stick them up there in the toolbar and use them. Okay, there's a right-click pop-up menu, really nice feature. Okay, it's customizable, and this is where you make your selections. Okay, and then save them. Okay, it's intended to provide fast access to your most commonly used functions. Okay, we recommend you keep the list short. Okay, but it's up to you. So if you right-click on any free space, you're going to get this pop-up menu. These happens to be the functions that I want. Okay. And from then, any point here, I just right-click here and go open. Right-click, get signals. Okay, right-click, get to integrate peak. It's really handy. Okay, font attributes can be customized and saved. So if you don't like Arial font here, change it. Okay, it's up to you. Okay, you can change the sizes as well. Okay, and then click the save button. You can save them for different categories. Okay, and just click the save button here. This is just a couple examples of places you can save. Unit selections, for instance, pick your units, hit the save button. Pick your graph options, save them. And I should just point out again that you can save graph options for different axes. You can also save graph options for different instrument types. So you can have one set of graph options for DSCs and another set of graph options for DMAs. You can obviously save all your analysis functions. And you can also load on the main options on this initialization page here. You can reload the program defaults. Okay, so in one fell swoop, you can reset the program back to the way it was in the beginning. Okay, it's really pretty handy. You can also enable multiple sessions of UA if you wish. So if you're starting to get into advanced stuff and you got a lot of files open, you wish you had another copy of UA open, if you go to the initialization page, check that box. You can open up multiple copies of UA. This is also where you open up multiple ini files if you want. Okay, so you can create multiple ini files and you can load customized ini files. So you can have an ini file for one guy and another ini file for somebody else. Okay. Now I'd like to talk briefly about the online help and support options you've got available. Okay, there's extensive information installed on your computer already. Okay, you really should take advantage of it. Help topics are meant for getting assistance while you work. For instance, if you pick the one that says analyzing data files, there's a list of all of these analysis functions with detailed explanations on how to use modify size, how to analyze a step transition. Okay, so it's a whole section here on how to analyze a glass transition. Really very good stuff. There's an interesting section here on how do I. Okay, so there's how do I analyze a glass transition, how do I determine DSC oxidation time, analyze DSC purity, etc., etc., etc. Okay, or how do I create an insert view? Okay, we blew over that in this class, but there's a detailed explanation of it in online help. Okay, there's also a user manual. Okay, it's actually really very good. It's 346 pages long. Okay, it's a Adobe PDF file. Okay, it's got a table of contents. It's got an index. It's paginated. You can print the thing out if you want. It's really got a lot of good stuff in it. A whole big chapter on analyzing data. Okay, so if you want some reading to do, you can print out the chapter on analyzing data and go to town. Okay. So that's basically it. Okay, we went through the basic steps of analyzing and printing data from a typical experiment. Okay, we talked about display options, how to get the data to look you want, a little bit about analysis functions, how to analyze transitions and what options you had and what results got plotted. We talked about how to get plots to a to a printer, obviously, and also to stuff like Word and Excel and PowerPoint. There's a lot of customizing ability in this program, and there's also a lot of online help and support options. Okay, so that's pretty much it. Okay, I tried to make this was an introduction to the new user. So I apologize if you were already beyond this stuff, but that's what it was intended for. Okay, there's another class which basically picks up where this class left off. So I hope you get the feel that UA is a very powerful and sophisticated data analysis program. Right? We've really only scratched the surface of its capabilities. Okay, we go into them and we basically pick up where we left off here in the next course. So if you want to get more into it, the Advanced UA Part 1 course is the next logical place to go. Okay, check out our website for future classes. There's already now, as of October, an Advanced UA Part 1 class, which picks up where this one left off, and there'll be other ones after that. Okay. There's other help available in QuickStart classes for specific instruments like DSC and TGA. There's also a full-day series of classes given in Delaware about every other month. We have various training opportunities available to you. We can get an application specialist to come to your site and give personalized training that you can customize. It can be a combination of theory and applications and hands-on training of software, basically whatever it is that you specify. That's done on a per diem plus expenses basis. Okay, and if you tune into our website, you can see various other training opportunities that we'll be developing in the future. Okay, if you need more help, okay, there's an applications hotline. Here's the phone number. Okay, we're there during normal business hours. Okay, there's also an email address that you can send questions into. We try real hard to answer those questions on the same day that they come in. Okay, often that phone gets very busy. There's just one person. There's a group of five of us that take turns answering that phone. I'm one of them, and sometimes we get a lot of calls in a day. Okay. So more often than not, you're liable to get voicemail when you call in, but we'll try to call you back as soon as we can. We try real hard to get calls back within a day. Okay, if something happens and you don't get a call back within a day, definitely please call back again the next day because we might have lost the phone number. Maybe the recording was garbled, or we wrote the number down wrong, or if you're not in our database, we can't look you up. If you think there might be an instrument problem, there's also a service hotline number here, 4050, that you can also call and talk to somebody in the service shop, and they can hook you up with your local service rep if you need it. Okay, and you can also contact your local sales and service representatives. They're actually very knowledgeable. Okay, so I hope you join us for other e-training courses, and for more information concerning those, you can visit our website. And if you have any specific questions about this course in particular, okay, there's a specific email address called webex2@taeinst.com that you can send questions to. So I'd like to thank you for attending, and I think that just about wraps it up. Okay, thanks.